As soon as we start making these functions, I'll start showing you how everything works, and I'll go back and I'll tell you how it all works, just in case you're worried that you don't know what's going on. So I'm going to take a look at these errors real quick, and this is going to be solved through a function. These two are solved through a function, and this is solved through a function. I don't know what's going on here, fireball. So let's check that out. 59 instantiate fireball. It seems straightforward enough. Maybe I didn't. Oh, see, I didn't put a capital B. I don't know if you copied mine letter for letter, but hopefully you put a capital B there. Control S, and let's see if that went away. And it did. Sweet. Okay. Go down to our search player function, and keep in mind that this is gonna pass the position. So if you remember me talking about how our patrol bot is gonna be running towards us, and how if we go behind the wall again, it's not going to know where we are. This is what's going to be called, is the search player function, and that position is going to be that last visible player position right here. So this is what he's going to do with that information. First, we're going to call, or not call, but define timeout to equal 3.0. And timeout is just going to be when he's going to give up. And the while statement, while timeout is greater than 0.0, while he's not giving up, we want to move towards position right here. Position. And if we can see our target, just return, because right now we're searching for a player. But if we can see our target, then we don't want to search for our player anymore. And we're not going to give any information back to the entire script. So just do a return if we can see our target again. Then, while search player is being called each frame, we want to make timeout minus equal time dot time times -1. So right now time out equals 3, and when this function is called again, we want to minus it by the time. So it's just going to be like 2.9 on the first one, and then on the 10th one it's going to be 2. So after like 3 seconds, it's going to equal less than 0 because of time. And this whole part is not going to be called anymore because of this boolean. So that's why that's there. And then yield. That takes care of our search player function. Now, the move towards and the rotate towards, they don't even make sense yet, so I'm going to do the rotate towards next. Function rotate towards, it's going to want a position to rotate towards. So position, and that's going to be a vector 3. First thing you do is to find a direction, and that direction is going to equal position minus transform dot position. Okay, and direction dot y equals 0. Now we want to do an if statement, and it's going to be looking if the direction magnitude is less than 0.1. So like right now our player is going to be rotating towards the position that where we're at, and if that direction is less than 0.1, then just stop rotating. That means that we got the direction that we want. And if we didn't have this, he would look all jerky and he would like keep on rotating to try to get the right one. But this just puts some damping on our rotating towards, so that is why that's there. And what we want to do is just return. After that, we want to transform. We want to define the rotation of a transform. So the rotation of a transform is a quaternion. So we're gonna have to work with some really cool quaternion functions. Slurp. And what slurp does, it's basically a smooth transition from one quaternion to another. So transform dot rotation. Oops. So it's gonna smooth rotate from this current rotation that we're at, and it's going to want the look rotation of direction. What look rotation does is it converts a vector 3 into a quaternion. See, as it says there, it says forward and then in quaternion, so that means it returns as a quaternion, and that's important because that's what slurp takes, is quaternions. So smooth transform from a current transform to the direction, and the direction is a position minus a current position. How smooth is going to be decided by the rotation speed, and then multiplied by time dot delta time. That way, well, my processor isn't that good, but it's different from a lot of other processors, like a P4, a Pentium 4 processor. It's gonna update the update function. It's gonna call the update function a lot more than a P3, and that's why we need to times rotation speed by time dot delta time, because delta time is the time it took to render the last frame. So after that huge rotation definition, we want to get rid of the Euler angles and make it equal vector 3 0 transform Euler angles dot y and 0 again. That way we want to get rid of x and z, the rotation of x and z. The x rotation is this. We don't want our patrol bot to be doing any of this rotation, and we don't want him to be doing this either, because no functions even call that. So we make this rotation equals 0 and this rotation equals 0. This is that y, that middle Euler angle, and that's what the only Euler angle that we want to be updating right here. The direction he looks at. So of course we're going to be talking about this one. I just used him to show you how to show you why I did that. So go ahead and save what we just did. Control S. And now let's do our move towards function, not our rotate. So you know what I'm going to do is I'm going to show you what rotate towards does. Yeah. And I think because I have errors, none of it's even going to him. But in theory, he should be rotating to wherever I am right now. Unfortunately, I have a bunch of errors and the script doesn't want to call, so our function move towards is going to give us some visual reference to look at. After we make this function, we're going to be able to experiment with this guy. So let's go ahead and do it. It's going to also take a position, just like rotate towards did. It's going to get a direction, just the same. Position minus transform dot position. And of course the direction dot y equals 0. Then if direction dot magnitude sets in 0.5, then just return, just so he's not freaking out that he's not precise on his movements, because, well, as human beings, we just kind of go in any direction we want, and hopefully it'll get us to that point. But with the computers, they have to be so precise, and we have to tell them, no, we don't want you to be that precise, and that's what this does. It's just don't worry about being more precise than this float value. So return, and then transform.rotation equals quaternion slurp. And you know what I'm going to do is just actually copy this, and I'm going to put it right here, just so we don't have to make you type a bunch. Slurp, open parenthesis, close parenthesis, semicolon. Okay. And I'm going to do the same. So just copy this, paste it, and don't worry about this anymore. Now make a variable called forward. And the following variables that I'm defining, they have to do with getting to that point, that position right here, in a certain amount of speed and with a speed modifier. So forward equals transform dot transform direction. What transform direction does is it converts from local to world, which is it's important when getting direction or forward. So vector 3 dot forward. So this line of code basically is wherever we're looking. That's what forward is wherever we are looking in the forward position. So var speed modifier is going to equal vector 3 dot, and this is going to be the dot product of the left hand side and the right hand side of two vectors. So forward and direction normalized. Then we want to make the speed modifier equal to math f dot clamp 0, 1, clamps between the value 0 and 1, and then returned it. So speed modifier. Oops, modifier. Yeah, I saw it right. And that probably doesn't make sense, because if we make speed modifier equal to this, why is speed modifier over here? Well, that's because it doesn't update speed modifier, the new definition, until the end of this line, until it gets to the next line. So right now, this equals this dot product. Alright? The direction is now going to equal forward times speed, and speed was defined up here. 3 if I remember, yeah, speed. And we'll also multiply by the speed modifier. Why am I doing all this? Well, in the character controller script, there is a function called simple move. And what simple move does is it moves towards a position with speed, and the other function that you could use to move towards a direction is just move on the character controller, but it doesn't move with speed, and I'll show you how it works. So after we define direction, we also want to get component the character controller and simple move. So you can see here it moves the character with speed, but the regular dot move function it just takes absolute movement deltas. Although it does motion and it's more complex, but we want just the regular simple move with speed. And we want to move towards direction with the speed and the speed modifier applied. So animation play run. Okay, that move function was a handful, wasn't it? But we can press Control S, save it, and let's see what he does. Yeah. Alright, so now he doesn't have any waypoints to look at, so he's not patrolling at all. But if he sees us, in theory, he should be chasing us right now. And then if I go behind this wall, he's gonna keep on moving towards this position right here until three seconds passes. So in theory, that's what he should be doing, but he's not. So let's go ahead and finish our patrol bot script. And it looks like we only have one more function to go, as I looked at the debug console. Yeah, it just said it wants the pick next waypoint function to exist, but it doesn't. The pick next waypoint function is just gonna have to do with our auto waypoint script. And if you remember earlier, I just went through it and I said none of this matters down here, but this function right here, which is find closest. So that's what the pick next waypoint function is going to do. So let's get started on that one.